Good morning, students. This is Manoj Kumar, Assistant Professor from Department of Computer Science, KIT Tiptur. So today we are going to deliver the lecture on machine learning, that is data pre-processing techniques. So what this concept will come under machine learning. So what are the pre-processing? Data is there. So pre-process means before they are fed as input. So you have to pre-process the data. So that when we consider as data pre-processing techniques. For example, you go with any machine learning algorithms. Okay. So before you apply the data, before you give the input to any machine learning algorithms, so what should be done? The pre-processing is to be done. So that one we will see in this particular lecture. So in so many things are there. So in pre-processing techniques, first you are going with a why you need to pre-process the data. Next, you go with a data cleaning, data integration, data transformation, data reduction, discretization, and other pre-processing techniques with research directions. So research directions may not be a good concern as you are studying. So, but you have to understand why you are performing a pre-processing the data. Next, you go with the data cleaning, integration, transformation, and reduction. Okay. So now so all these concepts will come, keep in your mind where it will be applied. So it will be applied in machine learning algorithms. Before you give the input for any machine learning algorithms like K-means algorithm, decision tree algorithm, backpropagation algorithm, that is ANN, next Bayes classification. So before you give the data as input for any algorithms, that data need to be pre-processed. Understanding, before you give the input is x, output is y. Before you give the input x to any of the machine learning algorithms, you need to pre-process the data. So what are why pre-process the data and what are the steps in pre-process the data, that we will see in this particular lecture. So why you are going for a pre-process the data, so that comes next. Okay, so in pre-process the data means data in the real world is incomplete and it is noisy and it is inconsistent. So that's why we take it as we pre-process the data for three reasons. One is if it is incomplete. Next, if it is noisy. Next, if it is inconsistent. So now you come for what is incomplete. Okay, so suppose you take a table. Okay, so of 10 attributes. So how many attributes are there? 10 attributes. So x1 is name, x2 is USN, x3 is address, x4 is phone number, like that. Okay, finally you will be getting the output as y. Okay, so if all the attributes, all the values of the attributes are there, then there is no problem. Suppose in age I have given 10 values. Okay, out of 20 values I have given 10 values. So at that time, what about the remaining 10? So 10 is not there. So all the values should be there in order to process the data. So that's why we tell, if it is incomplete, you have to fill the incomplete data. So how you fill the incomplete data, that we will see in the next process called as data cleaning. Okay, so data cleaning, so the how you get, so you can fill the incomplete data. So incomplete data can be solved. So it can be solved using data cleaning. So that I will tell you in the next coming lectures. So, so incomplete means if there is an attribute x of 20 values, but only 10 values are there, remaining 10 values are not there, then we are going to take it as incomplete data. So at that time, remaining 10 values you have to put and make it complete. Then we can process the data. Okay, so now you come for the second one, noisy. So what is the meaning of noisy means? Keep an example name. Okay, so name is there. In place of name, what should be given? if we give a name as A, B, or student S1, student S2, student S3, that can be the name. But if you give any other which are not related, for example, in place of name, if you give one, what is the meaning of that? So if it is S1, there is a meaning. If you, in place of name, if you give it as value as 1, so that value is called as a noisy. So noisy data is called any irrelevant data. So irrelevant data, we call it as noisy data. So noisy, removing the noise, it can be solved using smoothing techniques. So it can be solved using smoothing techniques. Okay, so that we are understanding, right? So noisy means giving the data against the type. So if it is the USN, if you give the USN as A, B, C, it is a noisy data. If you give the, well, for a name, if you give it as a 1, 2, 3, it will be the noisy data. So that can be solved using smoothing process. Understanding? So now you come for the last one, inconsistent data. So when you tell it is consistent, when all the values, suppose 10 values are there and 10 values are all equal, so then we tell it as consistent. So if there are not equal, suppose if I percentage, so first sem percentage 60, second sem percentage 70, third sem percentage 65. If it is in range of 60 to 70, so then we tell it as consistent data. So if the first sem, if you are having 60, second sem if you are having 70, and third sem you got 40%, so at that time what is the range? So it is varying. That's why we tell it as inconsistent data. So inconsistent data can also be solved. So that we will see in the next coming slides. Okay, so now you understood why you pre-process the data. First one, if it is incomplete, that means a attribute of 20 values are there, in that 10 as given and remaining 10 you have not given, so that data, incomplete data, cannot be processed. Second one, now you see, that means data is against the type, so then we tell it as a noisy data. For example, USN, you are giving it as ABC, and for names, you are giving it as 1, 2, 3. Then we consider this one as noisy data. Third one, inconsistent. That means the values are not within the range. If they are within the range, we call it as consistent. If they are not within the range, we consider it as inconsistent. So next one, no quality data, no mining results. So what you do, if there is no quality data means you won't get any data mining result. Result means, so you can take it, results are, so you can take it like this. I will tell you. So results are predictions what we make using various machine learning algorithms. So, so results are the prediction what we make using machine learning algorithms. Okay, so that is the mining results. Now you come for, now you understood why pre-process the data. One is incomplete, second one noisy, third one inconsistent. Now you come, this is the main thing, task in data pre-processing. Okay, so task in data pre-processing is first one, data cleaning. So this is the data. So much, this is the filled data. See here, if it is in brown, if it is said to be filled data with so many outlines. See here, so many things are out. You have to make it fit inside this box. So that one we call it as a data cleaning. Next, integrate. So these are the task in pre-processing. First one is cleaning. Next one is data integration. So data integration. So data integration means first you have cube. Next, this is the one dimensional. 2-dimensional. This one you go with a 3-dimensional, that is cube. So many types of data are integrated and placed inside a box. So this one is called as a integration. Integrate all types of data into one part, that is data integration. Next you come for data reduction. So reduction means one table is containing, this is the table of attributes, so many attributes that you are reducing the data. So reducing into, now you see A1 up to A126 is been reduced to A1 to A115. Similarly, T1 up to T2000 is been reduced to T1 to T1456. Okay, so these are the major tasks in pre-processing. Okay, so which are the major tasks? Cleaning, integration, next transformation, next reduction. Integrate is this one, transformation is this. So if you have integer data, convert that into float. So transforming one type of data into another type, we call it as a data transformation. So reduction means if there are n number of attributes with n number of transactions, that will be reduced to this part. So that is cleaning, integration, transformation and reduction. Okay, so now we shall see each and everything in today's class. So today's class we will discuss data cleaning, data integration and data transformation. Okay, comfort data cleaning. So data cleaning means what is the things you are going to do it. So kindly go with why pre-process the data. Everything will come here. One is, so see here, first one is incomplete, second one is noisy, and third one is inconsistent. Now you see here, incomplete means some values are missing. So this is said to be incomplete. So you have to match out there. So find incomplete means some of the values are not there. So for that one you are taking it as handling missing values, that is incomplete. So next one, after incomplete, what is the next one? Removing the noisy data. So handling noisy data. Next, correct. This is the inconsistent data. So this is for removing the inconsistency. I've already told you. Okay, so what is the data cleaning? First you get handling missing values, so handling outliers and smooth out noisy data, and third one, correct the inconsistent data. All these three will come under data cleaning only. So what is the reason for pre-processing? So all the three, incomplete, noisy and inconsistency, you are having it here. Incomplete, missing values, smooth out noisy data and correct inconsistent data. So come for the next one, handling missing values. Okay, so what you have to do, so many attributes are there. So take one attribute, that is x1, can be name. Okay, so x1 is an attribute, that is name. So how many values you should give? 20 values. So the missing values can be found only for numeric values. So numeric, for example, USN. So USN is a numeric type. So if there are, how to handle the missing values, out of 20 values, only 5 or 7 are there. So remaining, if there are not there, what you are going to do? So first one is ignore that tuple. Ignore that particular. If it is missing, leave that. Okay, usually done when the class label is missing. So when you don't have the class label means attribute name. So keep in your mind, so class label is nothing but class label is attribute name, like USN name, semester, branch, like this. So class label is missing. So then ignore that particular tuple. Okay, if the class name is there, so now you come for the imputation. So imputation means you are finding something to place the missing, to handle the missing values. So replace the missing values with the estimated ones. So first one is filling the missing values manually and missing the filling the missing values manually Like if it is marks 35, 40, 50, you can fill manually. Okay, so next, use the global constant to fill in missing. So if so many things are missing, you fill with a constant value. So like a constant 50, you take it for all the missing values. So this is missing value manually, whatever you can give, but here it is a constant. So once you give it 50, it all the missing values should be filled with 50 only. So next you come for the mean or median. So suppose there are 10 values, so 10 values are there out of 20. So 10 values out of 20 means, so what you have to do, so here the missing values can be anything. So it will not be the same for all the missing. So here missing values you can give it like 1, or you can give it like 2, or you can give it 3, whatever you want. But if you come for the constant, so here if you take any one value as 10, so 10 is the only value to give for all the missing values, for all the missing values. So next, use the attribute mean or median to fill. So if there are 20 values, out of the 10 values are there, 10 out of 20 will give you value something. So use the mean or median. Okay. So next you come for the most probable value. Okay. So this is the next one. So the most probable value means it is based on Bayesian formula or decision tree. We are going to use one probable value. Next you go up with the KNN imputation. So nearest value, if the above you have 5 and the below you have 6. So what is the nearest value? You can have it 5 or you can have it 6. So KNN computation means if the above row has 5 as value, and below row as 7 as value, then k nearest neighbor, so k nearest neighbor has a value that is 6. Okay, so that is KNN computation means if the above row has value 5 as value and below row as 7 as value, then k nearest neighbor value as the 6. So that 6 can be, so that 6 can be used for filling the missing value. So this is the concept. Okay, so this is up to handling missing values. So understand, first one is if no class label is there, ignore the tuple. If class label is there, fill the values manually, or you can use a constant value to fill all the values. Next, you can go with the attribute mean or median. Next, use the probable value or KNN computation. So that is up to handling missing values. So next you come for the noisy data. So noisy data means error or variance in measured variable. So for example, incorrect attribute values made due to data collection instruments, data entry problems, data transmission problems. So when you get the noisy data, so noisy data you will be getting when you don't have the knowledge of giving the value. So for example, USN, if you are giving the value as a characters, if you give the KI as a character for a USN, it becomes noisy data. Okay, so giving all the values with KI will also lead to the noisy data because it is against the data type. Because USN will go for the number type, but you are giving it as character type. So that when we call it as noisy data. So that means it is a error or variance. You are varying with the data type in the measured variable. Okay, variable means variable contains a value. So if you are giving a wrong value according to the data type, then we consider it as noisy data. Okay, so other data problems which require data cleaning are duplicate data, incomplete data, inconsistent data. So that is up to noisy. So how you handle the noisy method? So noisy method means you go with the binning method. So it is the most commonly used. So keep in your mind. So it is the most commonly used for used for noisy data removal. So it is the most commonly method used for noisy data removal. That is the binning method. Bin means it is a box. Okay. So first sort the data and partition into equal bins. Okay. That means if there are some noisy data, what you have to do? Okay. Then smooth by bin means bin median, bin boundaries. So this we will see with an example in coming slides. Okay. First, you have to sort the data and partition into equal bins. So then you apply these three methods. So three methods are binning by means, binning by median, and binning by bin boundaries. So after that, you go with the clustering. Next, you go with the regression, and finally with the combined computer and human inspection. So first one, regression is already been discussed. So now you go up with the clustering and binning method. So that we will see in the coming slides. So see here, this is the noisy data. So noisy data we have given like this. Okay, so sorted data for price. So see here, the data in dollars they have given 489. These are the data. Okay, so first thing is you have to partition into equal bins. So partition means how many values are there? You count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you make it 4 bins of 3 values or 3 bins of 4 values. Okay. So bin means it is a box where you place the data. Okay. So you make 4 one bin of 4 values. So I will be telling. So you make it, so one bin of 4 values. So 4 to 15 will be one bin. Next 21 to 25. Next you go with 26 to 34. So partition. So now as I told, bin, each bin is a box which consists of 4 values. So first 4, next 4, next 4. Okay. So now you perform the smoothing by bin means. So smoothing by bin means so what you how you calculate. So now you see you take this value. Okay. So what are the take these values? So binning by means so you have to calculate all the things. So that means 4 plus sorry. So it is 4 plus 8 plus 9 plus 15. So how much you will be getting if you add all this? So count for that. So you are having it is 4 plus 8 plus 9 plus 15. So that will result in 36. So 36 divided by 4. So how many values are there? So that is equal to 9. So that's why we are getting this one as 9999. So rather than placing here, so cut here. So inside the brackets I will place it here. So you are getting the value like this 9999 you have got it as, so all the values you are getting in terms of equal. So similarly now you go with the next one. So 21 plus 21 plus 24 plus 25. So how you will be getting that one? So calculate 21 plus 21 plus 24 plus 25. So you are getting it as What is the value you will get? Calculate. It is 91. So 91 you divided by 4. So 91 divided by 4. So that will get you 22.75. So 22.75 is equal to, we have rounded it to 23. So that's why we are replacing each and everything here. So similarly, you come for the next one. So next one is, what is the third one you are having? It is 26 plus 28 plus 29 plus 34. So 34. So this is equal to how much? So that you have to find out the 29 plus 34. So this is equal to 117, and finally you divided by 4. So 1 is equal to 117 divided by 4. So you will get it as 29.25. So 29.25 I am being rounding to 29. As you see here, if it is crossing 0.50, you round up to next number. If it is at 20.25, within 0.5, so you round up to 29 only. Okay, so that is the concept. So now you see how you get, all are equal numbers. So all these are different numbers, so that numbers we are again replacing. So understanding. So noisy data will come if it is against the type also. So here it is of different numbers. Now I am binning by means. So next you come for the bin boundaries. So go for the first bin. So first bin boundaries, which are the boundaries of the first bin? It is 4 and 15. So for 4 and 15, so you keep it as it is. So 4 and 15 remain same. Now in between what you have to take the nearest one. So what is the next number you have? 8. So 8 is very near to 4 or 15. So if which one is nearer? 4 is nearer. So that's why we replace 8 with 4 here. So you have to understand carefully. So which is nearer one, that you have to take. Okay. So which is 8 is nearer to 4 than 15. That's why 8 is replaced with 4 here. Okay. So next you go with the next one. 9. So 9 is very nearer to 4 or 15. So what is the difference between here to here? It is 5. 4 to 9 it is 5, and 9 to 15 it is 6. Okay. So 9 to 15 it is 6. So which one is nearer? 4 is nearer. So 9 is replaced with 4. So now you come for the second bin. So first and second will remain same. Sorry, first and last. So first one is 21. Second, last one is 25. So now you see what is the next number? It is 21. So 21 is very nearer to 21 only. So this one is keep it same. Now you see 24. 24 is nearer to 21 as well as 25. Then search for the range. So 21 to 24 it is 3, and 24 to 25 it is 1. So that's why we take it as 25. Okay, 24 is replaced with 25. Next you come for the next one. So 26. So 26 and 34 will remain same. Next you go compare 26 with 28 with 26. So this one is very nearer. So 28 is replaced with 26. So similarly now you come for 29. 29 is nearer to 26 by 3, and it is nearer to 34 by 5. So which is nearer, 3 or 5? So it is 3. So you replace 29 with 26 here. So that is the removing the noisy data. Now you see each and everything will be equal. So there are no different data. That's when we consider it as handling noisy data by binning. Okay. So next, which are the other? So others are clustering. So clustering is to detect and remove the outliers. So clustering is for detection and removing the outliers. Okay. So next you come with the next one, combined computer and human inspection. It will detect the values and check by human. So similarly you go with the regression by fitting into regressor functions. So which are the regressor functions? That is, you have gone with a single linear regression and multilinear regression. So that one we have to use it in this particular concept. So now you come for the next one, that is data integration. So what is data integration means? First one, placing all the data into one. So that we consider it as merging data from multiple sources. Okay, so what is the next? Entity identification problem. So entity means you have gone with a DBMS. So if it is, whether it is related to student or it is related to college or it is related to company, like that you have to identify the entities. Okay, so first one is if you are merging the data from various sources, so you have to check for entity identification. Okay, if the entities are different, what you will do? You are going to detect and resolve the value conflicts. Okay, so if the entities are different and they are not related to each other, okay, so what you are going to do? You are going to detect and resolve the data. For example, from one source you take it as college database, from other source you take it as company database. At that time, will the entity will be same? No, entities will be different because you have taken college database and company database, so both are different. At that time you have to resolve the data value conflicts. Okay, so finally redundant data occur when integration of multiple databases. So redundant means same attribute may have different names in different data types. So keep in your mind what is called as a redundant data. Same attribute may have different names in different databases. So that we call it as redundant data. Okay, so come for the next, how to handle the redundant data. So handling redundant data is first one, what is the redundant data? Same attribute may have different names in different data types, database. For example, attribute will be employee. Okay, so in other we can take it as employer or you can take it with employers also. So that one we consider it as same attribute with different names. So how you handle? By using object identification, derivable data, and by correlation analysis. So how you handle the redundant data? So by object identification, that is same attribute or object may have different names in different databases. Attribute or object may have different name in different databases. So derivable data, one attribute may be derived from another. For example, revenue. Next, detection by correlation analysis. Okay, so that is handling noisy data. So next you come with the data transformation. So I will be stopping up to data transformation, will not go to reduction. That we will see in the next coming lecture. Okay, so I will be ending with data transform. Transform the data from one form to another form. So how you transform? So now you see here we have gone with this concept. So go with the smoothing. So here 8 is a value. So 8 is been transformed into 9. So similarly 15 is the value that is been transformed into 9. So here 24 is the value that is been transformed into 23. Again 23 is the value. 23 is the value that is been transformed into 25. So that means you are changing the data. So how you transform? By using the smoothing technique, that is binning, regression and clustering. So, okay, first method for data transformation is removing the noise from the data. That will perform change the one value to another value. That one we take it as data transformation. Next one, aggregation, that is data cube construction. Next you go with a generalization. So what is a generalization means? So it is the concept of inheritance. So understand this one. So it is very, very important. So generalization means inheritance. So raw data are replaced with higher level concepts. such as street can be generalized to higher level like city or country. So street is a part of the city. Okay, it will be generalized as address. So okay, so street will be the child and city will be the parent. So next you go up with the other forms, that is very very important, normalization. So this is the case where you perform data transformation. So normalization techniques we have min max normalization, next we go with the z score normalization, next decimal scaling. So another method is attribute construction. So these are the data transformation. That means how you change the data. That is by smoothing, aggregation, replacing the child value with a parent value using generalization and normalization. So which are the formula? These are the formulas you have to take it for normalizing the data. So first min-max normalization, next z-score normalization, and decimal scaling. So that is these are the normalization formulas you have to take it. Okay, so this is up to data cleaning. We have gone with why pre-process the data, data cleaning, data integration, data transformation. So if you go with the right hand side, I have completed up to data transformation and remaining is reduction, discretization, other pre-processing and research. So that we will go with the next class. So I hope you have understood with this machine learning pre-processing techniques. So these are the lecture I will be giving to provide. Hope you understood this particular concepts. Okay, if you have this will be posted in YouTube. So kindly go through the video, learn the concepts and become pre-processor. Okay, so I'll be ending this particular lecture. Thank you all. Thank you one and all from all of you. Thank you.